Well, thank you. I know you had an alternative today. You could have gone and watched the keynote from Werner, so we really appreciate you dedicated folks coming and spending what I think is the last session of the day with us. So hopefully it's worth it. In fact, we know it will be worth it. You're going to walk away with some hopefully interesting ideas and things you can take back and apply to your own organizations. So this is SEC341. Automating IAM policy validation and analysis using GitHub Actions. If it's not the session you thought it was going to be, I'm afraid the doors are already closed, so you can't leave now. But please stick around. I think you'll get something out of it. My name's Mitch. I'm a solutions architect for AWS based in Sydney, Australia, and I get to work with our financial services customers. So identity is a pretty common topic that I spend a bunch of time talking about with them. And it's my pleasure to be joined here by Nitin today.
Yeah. Hi, everyone. My name is Nitin Kulkarni. I'm also a solutions architect in the identity solutions team based out of Arlington, Virginia.
So you've hopefully got an idea of what we're going to talk about from the title of the session and the synopsis if you read it. But and it's a code talk, so it's supposed to be a lot more practical and hands-on than it is slides. But we're going to level set with a few slides. We're going to try and keep them to an absolute minimum. But I just think it's important that you get the idea of where we're going with this, where we've come from, and the problem that we're trying to help solve with what we're going to present to you today. And then we'll get straight into the practical parts. We'll as we're going through this, because there's not too many people here, if there are questions, you can put your hands up and we'll have a go at answering them for you. Equally, if you want to wait till the end, you can do that as well. We're pretty flexible, I think, with timing at the minute. So what we're going to cover, traditional IAM models, and I'll explain what I mean by that in a second. We're going to give everyone a quick overview of GitHub Actions, but last time we ran this, which was yesterday, most people seem to already know what that was. Show of hands, who's using or used GitHub Actions? Yeah, okay, it's pretty similar to what we got yesterday, which is good. Then a quick overview of IAM Access Analyzer, which is going to form the basis of the practical part of what we're doing today and really help solve the problem that we're trying to solve. A quick introduction to custom policy checks, which is a feature of Access Analyzer, and then we're going to get into the building part of it. So what do I mean by the traditional models of IAM? In the context of today's session, we mean the way in which IAM policies in particular, and roles, and users in some cases, but essentially the things you create in the IAM part of the AWS console, how they're managed within your organizations. Traditionally, one of the patterns that we saw used quite a lot was the centralized model. And that's where there was a clear delineation between the security team and the software engineers within the organization. The security engineers would be responsible for creating the policies. They often created them in standard patterns, maybe t-shirt sizes with certain permissions based on persona, developer, knowledge worker, those kinds of things. Then the builders who are creating the software, the applications within the organization would have to use what they're given. They would be given a policy. It might be slightly overly permissive for what they needed, but it met their requirements. So that was the pattern that we saw used quite a lot in many organizations and maybe is still used in some places today. The challenge with this is that, well, several challenges. One is that the security engineering team tend not to know much about the applications that are being developed. So the policies can either be way too broad or way too narrow in terms of scope, making it hard for the software engineers to get the exact outcome they're looking for. The other challenge is that there are a finite number of security engineers. Any security people in the room here today? Yeah, there you go. So those are the unicorns. You guys will be asking for pay rises from your managers soon. I mean, there were some statistics I read that the cybersecurity industry is short there's some ridiculous amount, millions of security engineers. So if you want to change roles and practices, security is the way to go. So there are finite numbers of those, and not enough. And when the security engineering team is getting feedback from the software builders that they need to keep tweaking these policies, they become a bottleneck. So that's the centralized model. It doesn't necessarily work too well because you often end up with these challenges, these bottlenecks, and policies that are either too permissive or not permissive enough. Then we've got the gated model. This is slightly more in the direction that we think we should be going. This is where our security teams are essentially there to act as risk advisors, risk assessors, if you like, of policies that are being created. So the builders themselves who understand the applications will create the policies as part of their builder workflow. They may not fully understand the intricacies of the very expressive IAM policy language, but they'll have a good crack. They'll create a policy. They'll submit it along with their application code or whatever mechanism they use to submit these things. And then the security engineering team will step in and they'll review that. Better, because the policies are more scoped to what the application actually needs, because the app engineers understand it. Slightly more challenging from a security engineer perspective, because depending on how many times these developers are committing these requests for new policies, you could be backwards and forwards, backwards and forwards. The other challenge is, again, because you're a security engineer and you don't have the context of the application, a lot of the time you might be questioning why they've done certain things. And there can be tangos going on between the security teams and the builder teams as they negotiate, why are you doing this? Have you considered this? This is not best practice, backwards and forwards, backwards and forwards. If the policies themselves become, when they're analyzed by the builder team, by the security teams have issues, the developers will get notified by the security engineers and there'll be rework that has to be done. So better, but not perfect. And I'm not saying the next model is perfect either, but this is an improvement on the gated model. So this is where what we're doing with our security engineers is we're really going to allow them to use their judgment and skills to focus on things that we can't solve automatically. So instead of manually reviewing all of these policies or creating a bunch of policies and making them available to the engineers, the builders, what they do is they build automation so that when the builder submits their IAM policy, it will automatically get analyzed or assessed against a set of organizational standards, guardrails, best practices, whatever you want to call them and whatever you want them to be. If there happens to be a blocking change or a finding that's identified in that process, then the security engineer can be engaged, either automatically or through a failed build in a pipeline. They can have a look, they can have a conversation with the builder, or the automation can send notifications directly back to the engineer to say, it's failed, here's why it's failed, and then the builder has to go and figure out how to fix and resolve that problem. So better, definitely removing a lot of dependency on the security engineer there, allowing the developer to move much faster, and if their policy is good and well within the constraints or the scope, then it gets pushed straight out into whatever environment it needs to. And we're gonna kind of talk through that process today, but an evolution of that process, because one of the examples I gave there was that the builder gets the feedback automatically either from as part of the pipeline. I check it in, I've got a blocking finding, I get some feedback, I've got to go and figure out how to fix that. So we've enhanced the delegated model a little bit with what we're going to show you today to provide some of that prescriptive guidance, and you'll see more as we go through it. Right, GitHub Actions. What is GitHub Actions? For those of you that haven't used it, which didn't seem to be too many people in the room at all, it's essentially GitHub's native CI/CD automation platform and orchestration platform. It allows you to run actions, funnily enough, or arbitrary code in some cases, based on events that occur within a repository. This can be a committed change, it can be a pull request, it can be an issue getting logged. And these workflows, so the actions, the arbitrary code, if you decide to run that, will run on ephemeral runners, they're called. They can be managed by GitHub, or they can be self-hosted and managed within your own environments. These workflows get defined in YAML files, because everyone loves the YAML files. We're going to show you one of these workflows, in case you haven't seen one recently, in a little bit more detail as we go through the session today. Access Analyzer. What is Access Analyzer? Show of hands, who's using Access Analyzer? A few people. Okay, cool. So this is our automated reasoning-powered tool for analyzing your policies, be they identity policies or resource policies, to determine if certain properties are true or not true. In the case of the very first version of Access Analyzer that we deployed, we had an analyzer called External Access Analyzer, which is still available today. You should turn it on in your AWS accounts if you don't have it on because it's free, and it does a really good job of telling you whether or not things in your AWS account are accessible publicly. And it uses automated reasoning, so essentially mathematics, to give you mathematically verified answers to the question, is this thing true? Is this assumed property true? Is it public? Yes, no. Can this identity policy do this or that? Yes or no. And we call this at AWS provable security. If you Google search provable security, you'll be able to dive a bit deeper into that. That's pretty much all I'm going to say about automated reasoning and formal logic and provable security, because I don't have a PhD in that, and I do a really bad job of trying to explain the science behind it. But if you Google it, you'll find some really good examples of that and some really good papers that some of our colleagues have published in this space. One of the other features of Access Analyzer beyond External Analyzer and the other ones I mentioned as well is custom policy checks. So these are 4 stateless APIs that will use automated reasoning will mostly, for most of those actions, not validate policy. They'll essentially use automated reasoning or a variation of that to help you answer questions about policies that you want to check. So here's a policy. Does it conform to AWS 100 best practices, and is it syntactically correct? That's validate policy. Here's a policy. Does it allow a subset of my maximum allowable organizational permissions? That's custom policy checks. Check access not granted. Here's a policy. Check no new access. Here's a policy. Does it allow access to this resource, or does it allow access to this action? And that's what check access not granted is. And can anyone guess what check no public access does? We'll leave it there. So what are we going to build? What's Nitin going to build today? We're going to build this. This is a bit like our delegated workflow you saw on the slide a bit earlier on, with the added benefit of a little bit of intelligence when we get a failure. So when we identify a blocking finding, and we're going to use custom policy checks as part of this pipeline, so as a policy gets submitted and starts working its way through this flow, if we identify that that policy violates some rule that we've outlined, we will pass that finding and the policy that has failed over to Bedrock. And instead of just telling the engineer, nah, your policy's violated something, go figure out how to fix it, we're actually going to give the engineer prescriptive guidance generated by Bedrock and one of its many managed models on how to fix that. And not only that, because we're using GitHub Actions and our repository is in GitHub, we're going to generate an issue that contains that prescriptive guidance in a nicely formatted way so that the engineer goes, great, I can see here exactly why it failed, where I violated my organizational policies, and what I need to do to go and fix that. That's what we're going to build. I'm going to hand over to Nitin now to show you the build. Let's flip to there.
Awesome.
There we go.
Okay. Can everyone hear me well? Okay, awesome. Thank you, Mitch. So we are building automation in our CI/CD pipeline so that builder-authored or developer-authored policies can be validated against your security baseline, right? So the goal, and I'm reiterating the goal here, and we'll revisit the goal again when we go towards the end of this talk. The goal is to enable developer agility or builder agility at the same time by allowing developers or builders to write their own policies and roles, but at the same time enforce security team provided guardrails in the CI/CD pipeline itself, right? So this is kind of the overall goal. So let's get started. Now this slide, it gives an overall view of steps that we are going to follow. In the next 15 minutes or so, I will show you the whole build or the infrastructure setup, and then Mitch will come back and go over the actions code step by step, right? So let's get with it. So first 8 steps here we'll be performing using the persona of a security engineer. Mitch talked about that. This will set the pipeline, set the automation, set the plumbing and bells and whistles to make it happen. Then we'll come back as a developer or as a builder, we will check in a policy, and then that will essentially test out what we have built in the first 8 steps of this talk, right? So, okay, let's get started. I will first show, this is the repository we are going to use. I have cloned this repository locally. I will be using Kiro today, and we will also be using Kiro command line interface, which is a very nifty tool. It comes with a lot of bells and whistles, as I said, and we will be using this to over the code talk. Okay, so first, let us set up authentication between GitHub and AWS, right? So here, first we have created an identity provider in our AWS account. Pay attention to a couple of kind of configuration items here. One is the provider points to the OIDC endpoint of GitHub. We'll come to that quickly. And then also the audience is sts.amazonaws.com, right? So you might ask, okay, why are we going over this authentication from GitHub to AWS, right? We are here to do a code talk, right? It will be important because this is kind of an important pillar. The reason we are doing this is we don't want to vend out long-term credentials, or we don't want to store our access keys into GitHub, right? So for that, GitHub needs to get temporary credentials from AWS. In order, if GitHub has to make a call to Access Analyzer, as Mitch was saying, it needs to get temporary credentials. So the way this works is and we'll go over that process in this slide. When the GitHub Actions workflow runner is at a step where it needs to make a call to AWS services, it first reaches out to the GitHub OIDC endpoint. The GitHub OIDC endpoint returns a signed Java Web Token or a JWT or a JWT token. Now, among other things, this token contains attributes also known as claims, right? So for example, one of the claims in this token can be what is the repository name, what is the subject or the audience. These are the claims in this token. Once the Actions workflow runner gets this token, it then makes an assume role with web identity call to AWS STS service. Now, AWS STS service will then use the identity provider setup that we just created because is there a question? Yeah, sorry. Mm-hmm.
Yeah, sorry, the identity provider, do you have to set up one per account that you want to do this in, or can you set it up at the root management account and use it across your whole organization?
In this case, because you are going to make a call to that account, S3 account, you will have to set it up in the account level.
There's no way to do it.
The identity provider that you set at the org level is for org level actions, right? So for example, if you have to use IDC and then you want to use that identity provider to sync up users into your IDC and all that, right? This is a very specific OIDC identity provider that you will set up at this account level. Yeah, thanks.
Do we have OIDC for other repositories, management tools like Bitbucket?
So in this case, the OIDC endpoint is what matters, right? So as long as you have access to the OIDC endpoint, you can set it up. The reason why we need that OIDC endpoint is for authentication. AWS will reach out to the OIDC endpoint, get the public key, and then use that public key to validate the signature of the token that is presented to AWS account. So as long as any of these OIDC providers have an endpoint which have a key endpoint or which have a token endpoint, then we can use that. Make sense? Yeah. Yeah, great questions. Okay, so STS will then use the connection or the IDP that we have created to validate the signature on the token. That essentially completes the authentication process, right? Now we come to the authorization part. Sorry, let me take a step back. STS will validate the token and then return temporary credentials to GitHub Actions workflow, which are scoped to a role. And by the way, the role is also passed in the assume role with web entity call, right? Now let's quickly look at the configuration of this role that we have set up in our AWS account. So role in the role that is role scoped credentials, that particular role has got two different policies. One is the trust policy, and then one is a permissions policy. The trust policy defines what principals are allowed to make an assume role call to the role, and the permissions policy defines what permissions are given to the temporary credentials that are returned back as role scope credentials, right? So in our case, the role trust policy, we are narrowing it down to our repository in GitHub. So these two conditions that we have created here, one is that this subject condition and the audience condition. The subject condition narrows the principals that can make an assume role call to this role just to requests originating from our GitHub repository. So this clamps it down a little bit. And then sts.amazonaws.com, that is the audience, that is also one of the attributes in the JOT token, and that defines who this JOT token or what this JOT token is intended for, and in this case it's STS, right? So this is a pretty least privilege policy that we have in the trust relationship. The permissions relationship or the permissions policy that we have in the role, notice that we have permissions to 3 different AWS services. One is we have permissions to Bedrock, we'll come to that. We have permissions to S3 buckets. We will also see that in a minute, why we need that. And of course, we have permissions for Access Analyzer because we are going to make calls to Access Analyzer APIs from our GitHub Actions workflow. Okay, so we'll come back to our PowerPoint to just get ourselves situated. At this point, we have seen configuration for setup for the first 3 steps. And so we created the OIDC provider, we created the permissions policy, we created the role within AWS. Next, we will make a configuration setup in GitHub. So GitHub Actions workflow runner at runtime needs access to some configuration parameters. We don't want to store those configuration parameters or hard code them in the Actions workflow runner. So we do that at a place called secrets in GitHub. In our case, we have stored 3 different secrets in the repository. One is the AWS region, pretty self-explanatory. One is the OIDC IAM role, which the GitHub Actions workflow runner needs to make the assume role call, and then the S3 bucket. And we'll straight away come to why we need the S3 bucket here. Okay, so let's talk a little bit about reference policies. Now, Access Analyzer reference policies are a mechanism by which you can express your control or the intent for control, right? So what that means is that Mitch talked about the check no new access API in Access Analyzer. The way that API works is that you pass in the check no new access flag. It's a cfn-policy-validator wrapper to that. You also pass in 2 different policies to that API. One of the policies is what is called the candidate policy. In our case, the candidate policy is going to be the policy that the developer or the builder checks into our repository. And the next attribute or second attribute we pass is the reference policy. The way it works is if the candidate policy is not a subset of the reference policy, then that API returns a finding, a check no new access finding, meaning it says, oh, this, the candidate policy has new access than what is defined in the reference policy. So this is a pretty powerful kind of API that we can use at runtime for a lot of automation that we can think about, right? Now, in our case, as I said, we are going to pass the builder policy as a candidate policy. The security engineering team has already written these reference policies into the repository, and we'll see how that is set up. Now, before we go and look at our reference policy, I wanted to show a very handy kind of repository. Our colleagues at AWS have built a repository of reference policies. Now, this is amazing. There are a bunch of identity resource reference policies here. All the use cases are here. In case you are thinking of building this kind of an automation, strongly recommend, highly suggested to visit this and then get all these policies from here. We will show a link to this repository at the end of the talk. We'll show a barcode for that. But in fact, the reference policy that we are looking in our code talk today is also directly picked up from this repository. There are a lot of use cases also here. So a very nice resource to visit. So let's come to our reference policy. Now, the mental model or the way you can think about reference policies is similar to service control policies. So show of hands, how many of us are using service control policies? Yeah, I'm really glad. This is really good. This is more than what we usually see. So the service control policies and reference policies, the way we start off by giving all access, and then we add another statement in the policy which defines what access we want to control. So in this case, in our use case, we are saying that in our reference policy or the reference policy that the security engineer will check in, we are saying that if for all actions other than the assume role action, right? So which is the not action here, allow everything. So we are not concerned about anything other than the assume role action. But if the action is STS assume role, then only allow principals from these two accounts in the policy, which is in this case is going to be the candidate policy. Now, what would be kind of a real life use case where one would want to have this kind of a reference policy in the CI/CD pipeline automation, right? So Mitch and I, we talk to a lot of customers. We see customers multi-account strategy being around business units, right? So most of the time there will be, I am just making this up, sales business unit or marketing business unit, and each of these will be allocated 4, 5, 6 different accounts. The development teams that are building applications for these business units, if they are given access or if they are given permissions to write their own rules and policies, then there is no reason for any policy that is checked into a particular business unit to have assume role allowed from outside the 3 or 4 accounts or 5 or 6 accounts that are allocated to that business unit, right? So this is a pretty common use case that we see when we talk to our customers. So in this case, the security engineer is saying, okay, any policy that is checked into this repository, if it has an assume role action, then the principal has to be one of these 2 accounts, right? So let's now look at how or where this policy is stored. So in our case, in our automation, the security engineering team is storing, they're not adding this policy to the same repository. They are storing this policy into an S3 bucket, which is what we have done here. And at runtime, so this is now, that is the reason why you can make sense of the 2 things that we added earlier, 2 configuration items. One is we added the S3 permissions in our role permissions policy, and we also added S3 bucket into the configuration for our GitHub secrets, right? For which should be accessible to the GitHub workflow runner. Now let's come to the actual workflow code that puts everything together. Now, Mitch will go over this code, as I said, but one kind of configuration item here is that the way, and I think for those who are not dealing with GitHub Actions workflows, the way this works is any YAML file that you check into a .github/workflows directory in your repository is interpreted as a workflow or as an actions workflow by GitHub, and then it is executed in a runner as and when the triggers that are defined in the workflow are happening, right? So in our case, we have checked in this workflow into a .github/workflows directory as is seen here. So now let us go back and get situated into our steps, right? Okay. So we finished the authentication setup in the first 3 steps. We did the GitHub secrets, we created the reference policy, we talked about reference policies, we uploaded the policy onto S3, we created the workflow directory, and we created the actions workflow YAML file. I would suggest to just be patient, not to go through the YAML file. I will not go through it right now. Mitch is going to do that in a minute. Now let's come back and as a developer, we will test this out. So I'm a developer. My code is giving me access denied errors, right? What else is new? So I will show first the way. Okay, so this is the CloudFormation template that I am checking in, and I'm getting access denied errors. I have a deadline. What I will do is I will change the principal and make it principal star here, right? I have saved this. Now,
the classic troubleshooting step, star.
Exactly. I'm hoping that my CI/CD pipeline, I will no longer get any access denied errors. My CI/CD pipeline should succeed in this case. But if I am a security engineer, this is a classic no-no. I am hoping that the controls that I have put in the repository are going to not allow this to happen, right? So let me check in this code. Can everyone see? Yeah.
Yeah.
Okay.
Looks all right.
I am doing a git commit. And then I'll do a git push. Did that joke land? My daughter was telling me it will not land at all. She's like, okay, Dad, this is too lame. Why are you doing this? Sorry. Thank you. Okay, so I'm doing a git push. Okay, now, okay. So as a developer, I'm like, okay, now what else is going to give me an access denied? I have done, principal star, right? So I should not get the access denied at all. My CI/CD pipeline should succeed. Let us look at the way this pipeline is now getting executed. Yeah, we are going to our repository, and we go to actions. Because I used this already yesterday, so I'm using a 2 here. Again, a classic developer thing. So what is happening in these steps is GitHub then, based on the triggers, has loaded our YAML file and the steps and is executing the steps in our YAML file. Now, all this I don't have access. I'm not, as a builder, I'm not looking at all these things, right? I will go back and I will show you what happens. In my case, as a builder persona, I will take a look at this and see if my CI/CD pipeline succeeded, my code got deployed or not. At this point, you will see that we already have blocking findings, and the pipeline did fail. So if I go back to actions here, my pipeline failed. I got an email message saying an issue has been created. Now, think about this. The reason I talked to you, this is the issue that got created just now. Now, the reason I said, or we reiterated the goal earlier, is developer agility was our kind of goal, right? Now, prior to us being able to make a call to Bedrock in order to give us prescriptive guidance, as a builder, as a developer, what I just had to shift my troubleshooting from troubleshooting access denied error messages to troubleshooting why the CI/CD pipeline failed, right? Now, in this case, if you see the issue that is created, it tells me exactly what statement I checked in. It then tells me what is the reference policy that the security engineering team has put in here, has put in the repository. It tells me why this is a security risk, what is the intent of this kind of failure, and it also gives me the exact fix that I will have to do in order to fix this problem, right? So this is kind of really, in our mind, a game changer. We are really excited about the possibilities that we have here when we can make this call. So for example, what we are talking about is it possible for us to maybe not even have the builder write the policy? Some of us did talk about the Copilot launch yesterday, right? The Copilot release. So why not have Copilot craft a policy and
Autopilot.
then
Autopilot,
sorry. Autopilot, oh my God, that's a Freudian slip. So Autopilot craft the policy, then call GitHub, actions workflow, call access analyzer, check that the crafted policy is also, as per the boundaries defined here in the guardrail, and then go forward, right? So we are really looking forward if we can do something like that. At this point, we are not sure we can do that. But so what I am saying here is just a year back or a couple of years ago, this was not really a developer agility kind of enabling mechanism, but now it has taken a different kind of flavor. So I'm here. I got the actual prescriptive guidance as to why this CI/CD pipeline failed. I will go back and make a change to my policy, saying, okay, I will only allow the accounts that are allowed for me, right? I hope I typed the right number of ones. In this case, again, I will check in this code, and I will just make it a 2, only privilege gets allowed. Git push. So now I know for sure, or I'm fairly certain as a builder also, that because I have sort of adhered to what has been in the guardrails in the CI/CD pipeline, this actions workflow should succeed now. I guess maybe I hand it over to Mitch, and then once Mitch is done, we'll come back and see if the workflow succeeded.
Cool. Do you want to bring the workflow up on your?
Yep.
Cool, there we go. Excellent. That's it. So the first thing you'll notice is that we're using Kiro because Kiro's cool. In case you hadn't heard of the autopilot thing that Nitin was mentioning as well, so we launched this last week, pre-reInvent, and it's an MCP server for Kiro or any other MCP client that's out there, which it's called IAM Policy Autopilot is the full name for it. But it essentially will look at the application code that you have written, and it will generate an IAM policy based on the different API actions that you're calling. If you've imported one of the SDKs and you're calling S3 to list buckets, and that's the only thing that your piece of application code is doing, then the IAM policy autopilot will create just that policy for you. Least privileged, it has a lot of AWS knowledge and context, so it will make sure that the policy syntax is correct and accurate. It will aim to do least privilege where possible as well, and then you can commit that into the repo in the same way that we've just done with that policy a minute ago. So that's what that is, worthwhile having a look. It's pretty cool. So let's go through this workflow. If you've used GitHub Actions before, which most of you seem to have done, you'll be pretty familiar with what we've got here. The first few sections are fairly self-explanatory. We're only triggering when we are pushing changes to a certain branch. Anything below the kind of features / branch. We are only triggering it when there are changes to YAML files in a particular folder within the repo. So this is where we're changing a role trust policy. We are only triggering when it's a pull request as well. So those are the kind of conditions for triggering. Then we've got the permissions. This is where we're defining what the runners can do, so whether it's hosted or self-managed. ID token is essentially the permission it will need, the runner will need in order to complete the OIDC handshake to get the temporary credentials from AWS. The content permission is set to write, which means that the runner will be able to read and write content from the repository. And then the issues permission is set to write as well, because we want the runner to be able to create issues when it identifies these blocking findings. Now we get to the interesting part where things are a little bit different from maybe your traditional run and flow. So we've got a job. Our overarching job is called cfn-IAM policy-validation. The runner, you'll see, is just a fairly generic Ubuntu latest runner at the minute, one of the ones that we can get from GitHub's Actions environment fairly easily. This is hosted or managed on their environment. You can do a self-hosted version of this as well in your own environments. Why would you want to do that? Well, maybe your build process relies on some internal private repository for dependencies. Maybe you've got an Artifactory deployment, or you need to talk to a database to register your application with some configuration management code, something like that. So there are a few different reasons why you would approach that. Obviously, if it's in GitHub's own environment as a managed runner, then you wouldn't be able to access those private resources. But we've gone hosted for now. Then we've installed the fairly standard and well-used action for checking out code. That's fairly straightforward. Now we're installing an open source tool called cfn-policy-validator. This is a Python tool that was created by some of our colleagues at AWS that will essentially grok a CloudFormation template, extract the IAM-related resources out of it, and then pass them to the IAM Access Analyzer APIs to do the validation and any of the custom policy check capabilities that are brought up on the screen there. Then we're configuring the credentials, which is where our previous ID privilege comes into play. Fairly straightforward, with the exception of the fact there that we are using the secrets that we defined, or that Nitin defined earlier on, to extract some of the environment-specific information that we need, including the role name. Then we're fetching the resource policy, or the reference policy, should I say, from S3. So Nitin showed you that was already in S3 at the minute. You might have a pipeline or a mechanism to govern that process of creating those and pushing them into S3. I have a customer that uses DynamoDB to store these things, and they have, based on which team is doing the pull request or is pushing the code in, they pull down different reference policies and check the policies that the team is trying to create based on the persona or the team that's coming in. So there's a few ways of doing that, but essentially what you want to do is make sure that these reference policies are centralized so that you can access them as part of these workflows. You don't want them to exist within the context of the repo because that kind of defeats the object of having these centralized reference policies then. Now we're passing the CloudFormation template. So we're using the cfn-policy-validator tool. It has an argument or a parameter called pass. What we're doing there is we're essentially doing really what that tool does by default, which is scrape the CloudFormation template, extract any resources that are related to IAM, users, roles, groups, and policies, trust policies as well, and drop them into a file. We're going to come back and use that file a little bit later on. Then we're running the AWS Access Analyzer check no new access check. So this is where we're triggering the Access Analyzer capabilities. Now, what you'll notice here is where it says uses, we're using a native action called CloudFormation AWS IAM Policy Validator, which essentially is the same as the Python thing that we installed a little bit earlier on. And you might be going, well, that doesn't seem very efficient. There's a bit of duplication there. Why are you doing that? The reason we're doing it at the minute is that the native action doesn't include the pass functionality. So in order for us to do the thing that we're doing with Bedrock, and you'll see in a minute more about that, we need that pass functionality to take all the resources out, the IAM resources out. So if you didn't need to do the thing with Bedrock that we're going to show you in a bit, you could just use that native action, which is available in the Actions marketplace. You can install it and use it that way. Configuration is all fairly straightforward. You can see there, we've got the template path, so that is the template that we're analyzing in this scenario. Then we've got the reference policy, so this is the gold standard. No policy that gets created should have permissions beyond the scope of that one. We're defining what type of policy this is. So this is a resource policy because we're looking at, it's a role. We're analyzing a role trust policy. You may need to add a couple of different runs of that particular action there, or that step in the flow, if you wanted to analyze for identity-related policies. In fact, you would need to do it. It's not you would if you. Yeah, we don't. Unfortunately, at the minute, you can't just have like no policy type. Sorry, just scroll back up there for me for a second. And then we're choosing the region because you need to tell the API, the tool, which region it needs to use to call the Access Analyzer APIs. Then we're running now some kind of arbitrary code here just to try and get the results of the analyzer out of the check. So we've got the results back now. So we're passing that and we're trying to determine how many blocking findings there are. Now, we don't want to run the Bedrock part of this demo if there are no blocking findings. We only want to do it if there's blocking findings. So we're looking for blocking findings. We're analyzing that. We go down there, and what we're starting to do then is we're looking, if you can see down there, we're taking the outputs of some of these steps and we're putting them into GitHub outputs so that we can access them a little bit later on down the process. We are also now, so if you've ever used custom policy checks before, either directly using the SDKs or using one of the CLI tools, you will notice that the results and response you get back isn't particularly helpful, other than saying you got a blocking finding, and it was this policy that was the problem, and it was this statement index number where you've got the issue. If you've got a big policy that has lots of different statements within it, you're an engineer, a software engineer, for example, and grokking IAM policies isn't something you enjoy doing, then it can be quite challenging to go through that and kind of go to like 0, 1, 2, 3, that statement there. So what we're trying to do is we're trying to take that past policy that we passed earlier on in the step above, and we're taking the results from Access Analyzer, and it's going to say this policy name, this statement index ID. So we're doing the heavy lifting as part of this process to get the exact statement out of the policy that has the issue. Quick point, I've been talking about CloudFormation a lot. The cfn-policy-validator is specifically for CloudFormation. There is a tfn-policy-validator. Can anyone guess what that's for? Oh, there you go, see? So that's exactly. So you can do that as well if you were using Terraform. Where are we down here now? Okay, so then we've got our problematic statements in a text file. We are now writing the information into GitHub output so we can access it down in the next step of our workflow. So now we're kicking off the generate AI powered workflow, which is only happening if we have a blocking statement. So what we're doing is we're taking, I'll take a step back here and say, we're building a dynamic prompt as part of the next step of what you're about to see here. So we've created this prompt. We know what we want Bedrock to provide us. We've got some prescriptive guidance so we can give it back to the developer. So the next section you can see here is we're essentially adding the variables that we've created, which are populated based on the output from the different stages above. We're putting them into variables, and we're constructing now this custom prompt, this dynamic prompt, and we're going to start to inject into some placeholders there, which you can see, the reference policy, the validation result, and the problematic statements. So all of that now has been bundled together into a prompt that gets dynamically generated based on the specific results of that particular push. The things that we want to be consistent are how we want the prescriptive guidance to come back, what we want the model to do for us. So we've kept that in there, but we're just adding the dynamic bits in there as well. And we're giving it some very clear instructions there on what we kind of want it to do as well. How to update the CloudFormation template, check where it aligns with the reference policy. So we've been very prescriptive for the most part. Then we are taking that prompt that we've just built now that's been populated with all this really good information. We're writing it out into a JSON file. And then we are invoking the Bedrock API with the JSON file with the prompt in it, and it's doing its thing. And then as we scroll down a little bit more, in fact, there's the invocation part there. And if we scroll down a little bit more, we're going to get back then a response from Bedrock, hopefully, which comes with some useful information that we can pass on to the developer. So then we are now going to generate the GitHub issue. We're going to populate that issue with all of that information. We're going to make it look nice, so it looks kind of nice and friendly as well for the developer, with all the kind of clarity around what they need to do next and all the structure that you saw in the example earlier on. And that's it. That's how that mechanism works. So let's go back now and see if Nitin's push with the working trust policy looks as we expect it to look, which is no issue generated because he was using one of the trusted accounts.
Yep. So in this case, you will see that the next code push that we did with the correct policy, CI/CD pipeline succeeded. One thing here is that Mitch did mention that if the Bedrock or if the blocking findings are there, only then we call the Bedrock analysis. In this case, you will see that there is no blocking findings, so that's why we don't call the Bedrock analysis at all in this case.
So one of the interesting things about this as well that's worth keeping in mind is at the minute we're building these checks on the left-hand side of the policy development lifecycle, software development lifecycle, whatever term you want to use. There are going to be things that are already deployed in your environment that you don't want to happen in your AWS accounts. And you can use the existing analyzers to some degree to detect some of those things, especially if it's permissions that you don't want people to use or they shouldn't be using or they're never using anyway, DynamoDB delete table, S3 bucket delete, S3 delete bucket, any of the other things that you might not want them to use, and custom sensitive resources that might have been created that you never think anyone should be able to access other than maybe the security team or the legal team, that kind of thing. So as you've got the analyzers running in your accounts detecting the existing policies and the things that perhaps you want to apply as best practice, you can feed that back out into your reference policies or into a list of sensitive actions and sensitive API calls, which then can be scanned for or checked for using this mechanism the next time an engineer checks in the policy or the CloudFormation template that they're checking in. And this is kind of the cycle that will continue to flow then, this cycle where you identify a bad practice, you feed it back into the reference policy, it gets checked the next time someone builds something great. And you'll find over time you're just refining this and making sure that every new policy that gets created into your environment only contains the things that your organization is happy for it to contain, nothing more, nothing less. So that's how that will work, how we envisage that would work as well. So I think that's pretty cool. We think it's pretty cool. So, promised QR codes. These are massive QR codes, and I'll tell you why they're massive QR codes. It's because in a session I ran previously, not at this conference, at another event, I think I jammed about 5 or 6 QR codes onto one screen, and people's phones just could not focus on those QR codes. It was just trying to do this and this and this, so we've gone, right, you know what, we'll go one massive QR code per piece of content per slide. So we've got 3 huge QR codes for you. If anyone's phone isn't able to zero in on that, might be time to upgrade. Okay, so this workshop content will walk you through kind of what we've built today. And I say kind of because it doesn't include the bedrock part yet. And the only reason it doesn't include the bedrock part yet is that we just haven't got around to merging that new update into this. We will do. Someone asked me yesterday when we ran this session, when? And I said, because you asked so nicely, and because I've got a 15-hour flight back to Australia, I'll do it on that 15-hour flight. So maybe the next time you check that repo for the workshop content, it will be done. Blog post. This is a blog post. Yeah, let me do the QR codes, and then we'll come back to you. Sorry. Another massive QR code. This is a blog post that kind of talks about what we've just talked about today as well. The process, why it's useful, how to set it up and configure it, and also links back to the workshop as well. So if you didn't manage to get the last massive QR code, get this one because you'll find your way back to that workshop repository anyway. Okay, I can't see no more cameras. And then the last bit, policy samples. Okay. This is the repo that Nitin brought up earlier on. If you plan to build your own reference policies, if you want to do something like that we've shown you here today with GitHub Actions, or even whatever CI/CD tooling you're using, or if you just want to use access analyzers, custom policy checks through the command line tool, you can do it. But those reference policies are a really good place to start. We've got examples of reference policies that are good for resource policies and good for identity-based policies as well. So have a look at those. And then the last slide, oops, Daisy, I'm going to skip that one, that's not important, is this slide with our names and our contact details, of which we're very happy for you to reach out to us and email us, ask us questions, connect with us on LinkedIn, whatever you want to do. Because we love talking to customers about this kind of thing. And one really important item at the bottom there in the left-hand corner is please complete the session survey in the mobile application. And the reason that's important is because we want to know if you enjoyed this session, if you got something out of it, if you learned something, and if not, what could we do better next time to make sure that when we come back and do something like this again, it meets your expectations. So please, if you have some time, even before you leave today, please fill out the session survey. It is greatly appreciated. So that is the end of what we wanted to share today. Enjoy. Thank you very much for coming. Really appreciate it.
Thank you.